right now. So it's the right time to study about artificial intelligence and its associated field. One of the leading researchers in this field, Professor Andrew Ng, called AI as the new electricity. Why it's so? Because when electricity was invented, it transforms every aspect of our life, ranging from transportation, medicine, industries, and so on. Likewise, AI is going to have some impact on all these industries. But at the same time, AI is overhyped and underhyped. That means for some problems we can solve really well, and there are some other problems that are just out of the reach right now. So what exactly is AI? In layman terms, we can say that whenever we teach the machines to think like humans, then those class of technologies can be referred to as AI. Or in other words, we can say that it can be any technique that enables machines to mimic human behavior. One of the best example of AI device is the Sophia robot, which is the first humanoid robot or humanoid robot to receive the citizenship of any country. Sophia robot uses different technologies like facial recognition systems for identifying faces. She can imitate gestures. She can respond to certain queries. Likewise, so many features are incorporated in Sophia. The next best example of AI device is the Amazon Alexa, which is the personal assistant developed by the tech giant Amazon. We can interact with this Alexa. Suppose you need to know the temperature of your house. Then you need to give a query like this: Alexa, what's the temperature? Then the Alexa will reply with the current temperature. Likewise, if this device is connected to your home appliances, then you can control all your appliances. I can give a query like this: Alexa, turn off the front light of this drawing room. Then the system will automatically turn off the front light. The field of AI has produced a number of cognitive technologies. One area is the computer vision. In computer vision, we are teaching the machines to see. In computer vision, we are actually teaching the machines to see. This is one of the area. The next area is the machine learning. Normally, AI problems can be solved using rules or data. But when we solve AI problems using data, then we can call that class of technologies as machine learning. And the next area is the natural language processing. Natural language processing mainly deals with analyzing text. One of the best example of NLP is sentimental analysis. For example, after watching a movie, I wrote a review like this: the movie is not so bad. By analyzing the whole sentence, we can say that it's a positive review. But the word not is actually a negative thing. But after analyzing the whole sentence, we can say that it's a positive review. That is referred to as sentimental analysis. And sentimental analysis comes under the area of natural language processing. Next area is the optimization. Optimization mainly deals with picking up the best solutions out of the several solutions. That means for a problem, we may have different solutions. So you need to pick up the best one. So optimization deals with that. Next area is the planning and scheduling. Planning and scheduling means these are basically used for execution by the intelligent agents or autonomous bots. Next area is the robotics. Robotics mainly deals with the designing, building up, and the maintenance of robots. Next area is the rule-based systems. When we solve AI problems using rules, then we can say that it's a rule-based system. One of the best example of rule-based system is the doctor may use expert system for analyzing the disease based upon certain symptoms. And the final area is the speech recognition area. One of the best example of speech, here we are actually teaching the machines to listen. Okay, in speech recognition, we are actually teaching the machines to listen. One of the best example is the Apple Siri, and next is the Google's voice assistant. So these are some of the fields that comes under AI. Now we are going to the area of machine learning. So what exactly is machine learning? In short, we can say that is the ability to learn without explicitly being programmed. What's the meaning of this? I hope that all of you can see this figure. From this figure, we can say that machine learning is actually a subset of AI, or we can say that AI is the bigger umbrella, and inside that, there is a subsection known as machine learning. Consider that I'm giving you a problem. The problem is You need to write a program that needs to take a number and the output should be whether the number is even or odd. And for that problem, we have a logic. What's the logic? Take the number, divide it by 2, and if the remainder goes 0, then we can say that it's an even number. Okay, take the number, divide it by 2, and if the remainder goes 0, we can say that it's an even number. If the remainder is 1, then we can say that it's an odd number. You know the logic, right? If you know the logic, you can convert that logic into a program using any programming languages like C, Java, CPP, okay, or Python, whatever it may be. So here we are actually explicitly programming. But in the case of machine learning, we are not explicitly programming. It will automatically learn from the data. Okay, that is the meaning of this sentence, ability to learn without explicitly being programmed. Consider this as a machine learning problem. Suppose I'm again asking you to write a program that needs to take handwritten digit as the input. Okay, handwritten digit image as the input. And the program needs to tell what the image exactly is. It will be a very tedious task for you because each person have their own handwriting styles. The one can be written in different fashion, two can be written in different fashion. Likewise, these numbers can be written in different styles. So it is very difficult to write explicit rules for that. In that case, we can go for machine learning thing. Here, we can't create a function that actually maps input to output. If you are not able to find out the function, then my suggestion is that go for machine learning. Okay, this is the perfect example for a machine learning problem. So here, no well-defined function from input to output. So before starting into the concept of machine learning, we need to know some recipes needed for that. Firstly, you need to identify what is labeled data versus unlabeled data. Actually, in order to solve AI problems using machine learning, you need to have the data. The first task is to collect the data. Okay, so labeled data means it consists of XY pair. Okay, it consists of XY pair where X can be treated as the image and Y is the label corresponding to that. In order to teach the machines, we need to tell what exactly this image is. Okay, so we are feeding this image to the system and we are telling that it's actually a 5. Again, we are feeding this image to the system and we are saying that it's 0. Okay, likewise, this image can be treated as the X component and this label 5 is referred to as the Y component. So the label data consists of XY pair. But in the case of unlabeled data, this Y component is missing. That means we only have these images, but the system does not know what exactly the image is. Okay, so here it is written as unlabeled data misses Y component. This is the main difference between labeled data and unlabeled data. So how machine learning actually works? First of all, you need to have the data set. Data set means it contains a lot of data. It contains a lot of data. So here it is written as training data, and that is again labeled. Labeled means each image comprises, data set comprises of both X and Y component. We are actually giving this label data to our machine learning algorithm. Okay, we are giving this training data to our machine learning algorithm. So after seeing a lot of data, it will create a model for you. That means learned model is the output of this machine learning algorithm. Okay, this machine learning algorithm will output learned model. This learned model can be treated as a program. We don't know how to write the program. So we are giving that task to machine learning algorithm. So machine learning algorithm will looks on this data and it will create a program for you. You can directly, this program can be treated as a model itself. Okay, so this model can be taken and to this model, you can give the test data. That means if you are giving the image of 2 to this learned model, it will say that it's the image of 2. Likewise, if you are giving the image of 5, then the learned model says that it's a 5. Likewise, this can be treated as a model, but this time you are not actually programming it. The machine learning algorithm gives you the learned model. This is the concept behind the machine learning. So before starting that, we need to have the original data. You need to collect data. So that data can be represented as a data set. So first of all, we will have the original data. And you're again going to partition this data set into 2 categories. That is the training data and next is the testing data. Okay, first is the training data and second is the testing data. With the training data, we are going to train our machine learning algorithm, and with the testing data, we are going to test our machine learning algorithm. So this training data is again partitioned into two categories. One is the training data and other is the validation data. Okay, one is the training data and other is the validation data. This testing data is same as itself. So we have the machine learning algorithm. There are a lot of machine learning algorithms. We can pick up one of the best machine learning algorithm, and to this machine learning algorithm, we are supplying this training data. After seeing a lot of data, it will automatically generate a program for you. But during the training, you need to check whether this algorithm goes in a right manner or not. If it's not going in a right manner, then you need to tune that. Okay, normally we all know that in university, in colleges, we normally conduct series exams. What's the purpose of series exam? In order to check whether we are studying or not. Like that, before going to the university exam, we need to check whether we are going in a right manner or not. Likewise, while training, we need to check whether the training goes in a right manner or not. So in order to do that, we are using this validation data. After machine learning algorithm gives a model, you can directly take this model, and to this model, you can directly give the testing data. And this model will give you the prediction or the output. Okay, this is the concept behind the data set. This is the workflow of machine learning. First of all, you have the training data, and with the training data, you are going to train the machine learning algorithm. This machine learning algorithm will give you a model, that is the program itself. And to this program, you are supplying the new data, and it will give a prediction for you. If the prediction is wrong, then you need to again retrain the model. Or in other words, we can say that we are normally conducting series via remedial classes for those who scored less marks. Like that, we need to again retrain the model if the prediction is wrong. If the prediction is correct, then you can directly take this model and deploy it somewhere. Okay, so this is the machine learning workflow. So basically, machine learning is categorized into three types. One is the supervised learning, next is the unsupervised learning, and third is the reinforcement learning. Other than these three classification, there are also some other classification, but I am not going into those algorithms. Okay, so let's look what is supervised learning. So supervised learning means we are actually training our machine learning algorithm with the labeled training data. Okay, we are actually training the machine learning algorithm with the labeled data. That is referred to as supervised learning. One of the best example of supervised learning is, we know that when we got a mail, it will be automatically classified as spam or not spam. So there are two classes, that is spam or not spam. That mail can goes to spam box or it can goes to non-spam. So the machine learning algorithm will automatically tries to understand how a spam mail looks like. Okay, that is the example of classification, and classification comes under this supervised learning. In unsupervised learning, we are actually training our machine learning algorithm with the unlabeled data set. That means we don't have the Y component. Okay, we only have the X component, and with that X component, we are actually training our machine learning algorithm. If you're going to train like this, then we can call that type of machine learning algorithm as the unsupervised learning. So one of the best example is clustering similar documents based upon the text content. That means we have so many documents, and based upon the text document, it will cluster similar type of documents, but it does not know what exactly the document is. Okay, that is the example of unsupervised learning. And third is the reinforcement learning. Reinforcement learning means we are actually using that in games or in designing autonomous cars. Here there is an agent and an environment. Agent is continuously interacting with the environment. The agent will tries to get the reward. Okay, it will get the reward if it takes the right action. But what happens if it do a wrong action, then it will get a penalty. It always tries to increase the reward by reducing the penalty. That means it is studying based on the experience. So learn to play chess by winning or losing is one of the best example of reinforcement type of learning. So these are the main three classifications of learning. Then this supervised learning can be again classified into two types. One is the classification and other is the regression. When we look at this figure, here there are three animals. Okay, here there are three animals. That means we have three classes. So in classification, if you are giving the image of an animal, it will says it as cat, dog, or lion, like that. but we have only fixed number of classes. In this case, we have only 3 classes. The image will belongs to any one of these classes. In our handwritten digit recognition system, we have 10 classes ranging from 0, 1, 2, 3 up to 9. So given an image, it will automatically categorized into one among those 10 classes. That is referred to as classification. But in the case of regression, we are actually getting a continuous value. Continuous value means, suppose I need to predict the stock price. Okay, I need to predict the stock price. So each time it will predict a new value. So that new value can be treated as the continuous value. So that type of problems is called as regression type of problem. Or in other words, I can give you another example. So predicting the house price. Okay, predicting the house price. It's again a regression type of problem. So supervised learning is categorized into 2 types. One is classification and other is regression. Then we are going to the unsupervised learning. Unsupervised learning is basically classified into many types, but here I am concentrating on two main subsections. One is the clustering. Clustering means here the machine does not know actually whether this is apple or not. Okay, but based upon the similar patterns, it will cluster all the apples together. Here it will cluster all the bananas together. Here it will cluster all the mangoes together. But when we look at this, we can say that based upon the color pattern, it clusters both mangoes and bananas together. But the machine does not know whether this image belongs to banana or mangoes. It will cluster all the apples together based upon the color or some patterns. Okay, so here we don't have any Y component. But this type is known as clustering type of problem. Next is the association. Association means, for example, after purchasing a laptop from Amazon, the Amazon will suggest you to buy a laptop bag. After buying a specific thing, it will suggest some related things in the next time. Okay, that's the concept behind this association. So association and clustering comes under the area of unsupervised learning. So what exactly is computer vision? And I'm going to get into the area of computer vision in the upcoming slides. So computer vision means we are actually training the machines to see, or we are making the machines to see. Or in other words, we can say that it's the process of making computers to gain high-level understanding from images and videos. Okay, this section is called as computer vision. Again, we know that cameras are everywhere. In cars, we have the cameras. In a surveillance system, we have the cameras. In drones, we have the cameras. In shops, we have the cameras. In mobile phones, we have the cameras. Likewise, cameras are everywhere. So we are getting lot of images and videos through these cameras. So we are going to utilize these images and videos for the upcoming, for solving some problems. Before going to the concept, we need to look what exactly an image is. Okay, so here I am showing you an image, and I am going to zoom this nose part. Okay, I am going to zoom this nose part, and it will look like this. Okay, it will look like this, and you can see some small squares here. Okay, these small squares here. These small squares can be treated as the pixel. Okay, these small squares can be treated as a pixel. So we can say that pixel is the smallest unit of a digital image. Okay, so pixel is the smallest unit of a digital image. And this pixel value ranges from 0 to 255. This pixel value ranges from 0 to 255. That means 0 for perfectly black and 255 for perfectly white. Okay, 0 for perfectly black and 255 for perfectly white. And all other values in between 0 and 255 can be referred to as different shades of gray. So what happened if the value is 56, it is actually going to the black area. Okay, when the value is 59, it is again going to the black area. When the value is 134, it is going to the higher values. Okay, so it's a gray scale, gray color. Exactly 127 means it's an exact gray color. Okay, so all the values between 0 and 255 can be referred to as different shades of gray. So in order to represent 256 combinations, we need to have 8 bits. Okay, in order to represent 256 combination, we need to have 8 bits. So 8 bits are used for each pixel, representing each pixel. So pixel is the smallest unit of an image. And this is a grayscale image. And keep note that grayscale image has only one channel, or grayscale image has only single channel. So this is the concept of color image. Basically, color images comprises of 3 channels. One is the red channel, next is the green channel, and third is the blue channel. For each of this channel, we have the pixels. Okay, for each of this channel, normally what will happen in this blue channel, each component will use 8 bits. In green channel, each component uses 8 bits, and in our channel, each component uses 8 bits. So altogether, a pixel in color image uses 24 bits. Okay, 24 bits. When we combine all these three channels, we will get the color image. This is the concept of color image. And here we have three channels, but in the case of grayscale image, we have only a single channel. Okay. So here we can see the area of computer vision. So computer vision contains so many problems, and some of the problems are actually overlapping with artificial intelligence, machine learning, and deep learning. And there are also some other problems that is nothing to do with these technologies. Okay, so we are mainly focusing on some of these problems that comes under this machine learning and computer vision, and again some problems comes under this deep learning and computer vision. So this is the related disciplines. We are going to integrate all these fields. Okay, so why I chose computer vision? So 30% of our human brain is devoted to vision when compared to 8% of touch and 3% of hearing. That means vision normally begins with eyes, and it will truly take place in the brain. So 30% is devoted to vision. That's why I'm taking this computer vision as the main area, right? So have a look at this picture for a few seconds, and I'm going to ask you something. Okay, have a look at this picture. You need to directly interact in the chat box. Okay. I hope that it's okay with you all. So now I am going to ask some questions. So how many peoples are there? How many peoples are there? It's a question for you. How many peoples are there? You can use the chat box. How many people are there? 7, 6, 8. Okay, right. 7, 6. Okay, exactly. We can say that it contains 6 to 7%. Okay, that's good. That's good. Again, the next question, what are they doing? We know that. What are they doing? Okay, right. What objects the person on left standing on? What object the person on the left standing on? Once again, I will show you the picture. What object the person on the left standing on? It's a scale, right? It's a scale, or it's a weighing machine. Okay, that's good. Why this is a funny picture? We know that why this is funny, but the computer system is not able to identify what's the funny thing happening in this picture, right? Okay, so it will be very tedious task for the computer to find out the funny thing, but we can count the number of persons in this. First person, second, third, fourth, fifth, sixth, and 7 persons are there. Okay, in this picture we have 7 persons, but some fake persons are also there, because these are the mirror images. The computer need to identify this as mirror images, so we can't count this as person. That thing the computer can identify. Okay, it's okay, and computer can identify the weighing machine. So what exactly the funny thing? This man is actually standing on a scale, and Obama is applying some weight on the scale, and he's not knowing about that. And when we look at the screen, he found overweight. Okay, and others are seeing this and they are actually laughing. This is the funny thing happening inside this picture. But the computer is not able to identify all these funny things, but our human brain does. Okay, that is the beauty of our brain. Okay, we need to train computers to do such wonderful things. Okay, we are trying to do that, and it may achieve that. Okay, whatever it may be, I'm skipping that thing. So this shows the relevance of computer vision, right? So now I'm going to talk about human brain. We have learned more about the brain in the last 5 years than we have learned in the last 5,000 years. So we know that it controls every aspect of our life. Okay, whatever it may be, still we don't know how exactly it works. Okay, still we don't know how exactly it's works. The brain on pattern recognition. Our brain is able to identify that all these images contains cat. despite the changes in deformation. These images contains cat, but these are some deformed images, but our brain is still able to find out that we need to solve this challenge in our computer vision projects. Okay, we need to solve this challenge in our computer vision projects. Despite the changes in illumination, humans are still able to identify that all images contains cat, but the system needs to classify all these things as cat. Okay, that is another challenge despite the changes in illumination. Despite the changes in occlusion, if there is an occlusion, then still our human brain is able to identify that. But the computer need to identify all these things. So it's again a challenge. Okay, when occlusion happens, it needs to tackle that problem. Okay. Despite the changes in size, pose, and angle, we are still able to find out that, but this is again a challenge to the computer vision problems. Despite the changes in background clutter, here you can find out that the cat's fur color is similar to the color of the soil. We are able to find out that in this image, there is a cat. Here, the eyes color is similar to the fur color of this cat. Okay, right. So despite the changes in background color, our brain is able to identify that, but we need to tackle this thing in the computer vision domain. And finally, despite the changes in class variation, there are different variations for each object. Or we need to train all these types of variation. Otherwise, the system will not say whether this image belongs to cat or not. Okay, so our brain has the capability to identify all these stuffs, right? These are some of the challenges in the computer vision domain. Again, there is a paper called The Past, Present, and Future of Computer Vision. If you are interested more in computer vision, you can directly go to this paper. And this is a paper by Trade. And of course, it takes around 15 or 20 minutes read. It's a very beautiful paper. Okay, you can read that. Again, I am asking you a question. Please keep note this picture in your mind. What's the color of B and I when compared to the letter A and S? What's the color of B and I when compared to the color of A and S? Is it same or not? My question is that, is this same or not? Okay, you can directly give that in the chat box. Is that same or not? Some of them are saying that it's same. Okay, some of them are saying it's no. For the first time, when I see this picture, I said that both the colors are different. Because when we look at this image, we can identify that the colors will be different. But when we concentrate on this picture, please look at the cursor. Okay, please look at my cursor. Here the color will be similar to this color. Okay, here this color is similar to this color. Okay, it's okay. So the color will be same. Here also, when we look at this, here the color is similar to this color. That means B, I, A, and S uses the same color. But our human brains makes a mistake here. Okay, but our human brains make a mistake here. But for a computer system, it will surely tell that all these letters contains the same color. There are some cases where the computer system will give the right answer and we will give the wrong answers, right? This is referred to as the unconscious bias. Okay, this is referred to as the unconscious bias. Okay, then I'm going to the area, this area. So we are going to, I already said that there are a lot of problems in this computer vision. So we are picking up one of the problem in computer vision that is actually overlapping with this machine learning area. Okay, so we are picking up one of the problem that is actually overlapping in this computer vision domain and machine learning. So image classification is the basic type of computer vision project that we can do. And there are also some other problems like image detection, image segmentation. Okay, anyway, we are now concentrating on image classification. What exactly is image classification? The thing is that given an image, the system needs to identify what exactly the image is. If you're giving the image of a cat, it needs to say that it's a cat. If you're giving the image of a dog, it needs to say that it's a dog. If you're giving other objects, then it needs to specify that these all are other objects. Okay, that's the problem here. Okay, and this problem is referred to as the image classification problem. So now how we are going to solve this problem? So in machine learning category, we are saying that the first step of machine learning is to obtain the data set. So in order to train our machines, in machine learning, we are actually training our machines with the data, or we are solving AI problems using data. So first of all, we need to collect the data. So I need to collect lots of images belongs to cat, lots of images belongs to dog, and lots of images belongs to other animals. Okay, after that, I'm going to take each image and perform some pre-processing. Pre-processing means this image is actually rotated. I'm going to rotate it like this. So some pre-processing is done, and this image is resized into 256, say across 256. That means, please don't draw in the slides. Okay, we are actually converting that into a pre-processed image. That means this pre-processed image comprises of 256 cross 256 pixels. That means it contains 256 into 256 pixels, and this contains 3 channels, that is RGB. Okay, this step is called as pre-processing. Next, after the pre-processing step, we are going to convert this pre-processed image into feature vectors. Okay, after the pre-processing step, we are converting this pre-processed image into feature vector. So what exactly a feature is? So the question is, what exactly a feature is? Again, here we can see some red dots. Here we can see some red dots, and all these red dots are clustered together. We can imagine these dots as cats. Okay, we can imagine these dots as cats. So all the cat images belongs to a cluster. Here it is written like, these are the properties of a good feature vector. Data points in the same class should cluster together. All the points in the same class are clustered together. Again, the second property, these blue dots can be treated as dogs. Okay, all these dots belongs to the same cluster. So this is one class and this is another class. So we can say that data points belonging to different classes should be far away. Yeah, exactly. It is far away from these two classes, right? There are some spaces between these two data points. Okay, it's good. That's a property of good feature vector. Again, keep essential information. That means if I'm asking that whether this image contains a person or not, you can simply identify that, yeah, of course, this image contains a person. You can simply tell that this image contains a person. I'm asking that who is this person? Who is this person? Who is this person? We know that it's messy, right? We know that it's messy. For a computer system, it will be very difficult to identify that. We know that based upon some brain mechanism, we are still able to identify that this man is messy, right? So the first problem is that I am asking you whether this image contains person or not. And for a computer system, it can easily answer that this image contains person. So keep the essential information that is related to your problem. If I am asking you about what's the color of the jersey, can you tell that what's the color of the jersey from this image? Can you tell that what's the color of jersey from this image? No, we can't tell the color of jersey because that information is not there. So in order to solve that problem, we need to have the original image. Okay, we need to have the original image. From this image, we can say that the color of the jersey is blue, right? So based upon your problem, you need to keep the essential information and throw away the extraneous information. And these are some of the properties of a good feature. Okay, good feature vector. Again, there are different features for different problems. We have different type of feature descriptors like hard features. Hard features are basically used for identifying the phases. Hard features are basically used for the problems for detecting these persons. Okay, like that we have different type of features for different problems. We need to pick up the best feature descriptors for that. Okay, that's a challenge. That's actually a challenge. So we have feature descriptors like shift, surf, hog, brief, op. These are some of the feature descriptors, and based upon the problem, we need to pick up the best thing. Okay. Now we are going to the third step. So firstly, we will take the image, and then it is converted to a preprocessed, then we converted that into a preprocessed image. After that, we convert that into a feature vector. This feature vector is given as the input to a machine learning algorithm. Keep note that this feature vector is given as input to a machine learning algorithm. So our basic problem comprises of three classes. What all are they? Cat, dog, and others. So we have three classes: cat, dog, and others. If the learning goes in a perfect manner, it will give a model for you. And to this model, you can give directly an image, and it will say that if you give the image of a cat, the learning algorithm tells with 97% probability, it's a cat image. Okay, with 97% probability, it's a cat image. With 2% probability, it says that it's a dog image, and with 1% probability, it says that it's an other animal. Okay, that's the concept behind the machine learning. Again, one of the most commonly used machine learning algorithm is the support vector machine. Okay, support vector machine. So this could be treated as cats, and this could be treated as dogs. Okay, this could be treated as
Hello?
Please unmute your mic. Please unmute your mics. Okay, so these dots can be treated as cats, and these blue dots can be treated as dogs. Can you separate these two classes with a single line? I'm asking you about that. Okay, can you separate these two classes with a single line? I'm asking you. You can directly give that in the chat box. Can you separate these two classes with a single line? Is there any possibility to separate these two classes with a single line? Yes, with a single line we can separate these two classes. But in reality, images are multidimensional. But for our simplicity, I am saying that suppose this image, suppose we can assume like this: images comprises of two-dimensional data, but images are multidimensional. In reality, images are multidimensional data, but for simplicity, we are assuming it as two-dimensional data. So we can separate this with a single line. Okay, we can separate this with a single line. So the support vector machine or this type of machine learning algorithm will find, say, line for you, so that this line separates both these classes. So when we test with a new image, suppose that image comes to this portion. Okay, suppose that image comes to this portion. We can say that all the points above this line can be treated as image. So the new tested image is actually a cat. If the data points belongs to this portion, we can say that it's a dog. So support vector machine gives you the line that classify both these two classes. Okay, so this is the concept behind support vector machine. But in reality, this is actually a simple case. Okay, I'm again asking you that suppose the data points are like this. Suppose the data points are like this. Can you separate this with a single line? Again, I'm asking you, can you separate this with a single line? Yeah, of course, it will be difficult for you all. We can't separate this with a line. So what we can do? So there is a trick for this. Okay, we have to use planes. That's the right answer. We have to use planes. Let's look how we can directly use the planes. So here I'm going to convert this two-dimensional data. This is actually a two-dimensional. Abhiram, please don't draw in the slides. It will be disturbance for all of us. That's why. So this is actually a two-dimensional data. This two-dimensional data is converted to three-dimensional data. That means in two-dimensional data, we only have the X and Y component. Okay, in two-dimensional data, we only have the X and Y component. But in the case of three-dimensional data, we need to cook up a third dimension, say C. Okay, we are creating a new dimension C from X and Y. So we are going to convert this two-dimensional data into a three-dimensional data. Can you separate this three-dimensional data with a plane? Again, I am asking you guys, can you separate this three-dimensional data with a plane? Of course, you can separate this three-dimensional data with a plane. Okay, so let's look that. So this is the plane. Okay, now we are converting a linear problem means suppose this is a non-linear problem. When we are able to separate it with a line or hyperplane, then we can say that it's a linear problem. But this case, it's a non-linear problem. We are converting this non-linear problem into a linear type of problem. Okay, then we are going to separate both these classes with a hyperplane. So support vector machine uses a kernel trick. So this kernel trick can cook up a third dimension so that it can be better partitioned with these dimensions. Okay, so this is the concept behind the support vector machine. And next, we are actually solving this problem by using a third dimension. So this is the concept behind the support vector machine. Now we are going to the entire image classification pipeline. So firstly, we have the input image, and this input image is then converted to a pre-processed image. So this pre-processed image is converted to a feature vector. Okay, this can be treated as a feature vector. This is the relevant or the sufficient information for a machine learning algorithm. Keep note that this is a relevant or sufficient information for the deep learning algorithm. It does not need to have all these colors. Okay, from this we can see small eyes here. Okay, we can see small eyes here and nose. So with these data, this is referred to as the features. Okay, with this data, machine learning algorithm is going to learn all these stuffs. After learning lots of data, it will automatically says that what the image belongs to. Okay, so features like har, hog, shifter, there are so many features like this. So learning algorithm can be of different types like SVM, random forest, artificial neural network, like that. So we can use the appropriate learning algorithm for this purpose, and after that it will give a prediction for you. It will say that whether this image belongs to cat or not. Okay. Now, in the last 10 years, AI and ML have shown tremendous progress. But much of the current excitement concerns a subfield of it called deep learning. So deep learning is a new field. So what exactly is deep learning? I will tell you in the upcoming slides. Again, we are concentrating on the second part. We can say that from this figure, we can say that AI is the bigger umbrella. Inside that, we have the machine learning. So machine learning is a subset of AI. Inside this machine learning, we have another category called deep learning. So we can say that deep learning is a type of machine learning. Okay, deep learning is a type of machine learning, or we can say that deep learning is a subset of machine learning, right? So deep learning is a subfield of machine learning concerned with the algorithms inspired by the structure and function of the brain called artificial neural network. So with the help of artificial neural network, we are actually creating this deep learning algorithm. Actually, deep learning algorithms are based on artificial neural network. So this is trying to mimic our human brain. Okay, this is trying to mimic the human brain. So this is the relationship. AI is the bigger umbrella. Inside that, we have the machine learning, and the subfield of machine learning is referred to as the deep learning. So before going to that, I need to show you some video. You need to tell whether you're able to see the sound. So this is the Amazon Go video.
4 years ago, we started to wonder.
Are you able to hear my sound? Is that okay? Are you able to see my screen? Please mention that in the chat box.
Yes, sir. Yes,
okay,
sir.
Okay, right. I'm going to play this.
Four years ago, we started to wonder. What would shopping look like if you could walk into a store, grab what you want, and just go? What if we could weave the most advanced machine learning, computer vision, and AI into the very fabric of a store so you never have to wait in line? No lines, no checkouts, no registers. Welcome to Amazon Go. Use the Amazon Go app to enter. Then put away your phone and start shopping. It's really that simple. Take whatever you like. Anything you pick up is automatically added to your virtual cart. If you change your mind about that cupcake, just put it back. Our technology will update your virtual cart automatically. So, how does it work? We used computer vision, deep learning algorithms, and sensor fusion, much like you'd find in self-driving cars. We call it Just Walk Out technology. Once you've got everything you want, you can just go. When you leave, our Just Walk Out technology adds up your virtual cart and charges your Amazon account. Your receipt is sent straight to the app, and you can keep going. Amazon Go. No lines, no checkout. No, seriously.
So this is one of the example of AI. And now I am going to show you another AI device. That's the Echo Spot, which is the advanced version of Amazon Go. Okay. So
Meet Echo Spot,
Hi there.
a compact Echo with a screen that can show you the time, the news, your music, and a whole lot more. With Echo Spot, you can customize Alexa to help you rise and shine.
Alexa, good morning.
Up and at 'em, Tiger. It's 45 degrees with partly cloudy skies. Here's your flash briefing.
Start your day with a forecast, commute times, or the latest trending news. Staying in touch is simple. Call just about anyone hands-free, or make video calls to family and friends with an Echo Spot, Echo Show, or the Alexa app.
Alexa, call Jess.
Calling Jess.
Hey, what's up?
Hey,
Is everything okay?
Just ask to play music from Spotify, Pandora, Amazon Music, and more.
Alexa, play Emily King.
Shuffling songs by Emily King.
Listen through the built-in speaker, or for even more sound, connect Echo Spot to your external or Bluetooth speakers.
Alexa, turn it up.
Echo Spot works with compatible smart devices to set the temperature, turn on the lights, or check in on the little one.
Alexa, show me the nursery.
Okay.
And with the adjustable stand sold separately, you can see everything from the perfect angle.
Good night, little guy.
With tens of thousands of skills and counting, Alexa is always getting smarter, and so will Echo Spot.
Alexa, good night.
Sleep tight.
The all-new Echo Spot from Amazon.
So these are some cool applications of AI. Okay, now we can go to the concept of deep learning. I hope that you enjoyed this video. So let's go to the world of deep learning. In machine learning, we normally need to extract our data, right? In machine learning, we need to extract our data. That means we need to handcraft, we need to build some hand engineered features. Okay, we need to build some hand engineered features. In our earlier case, we uses the feature descriptors like hog, surf for that. But these are time consuming because we need to design such type of good algorithms for the better performance. Here we are trying to whether we can learn underlying features directly from the data. That means without any handcrafted features like shift or surf, can we able to train our machine learning algorithm. But in deep learning algorithm, we don't need any hand engineered features. Keep note that. In machine learning, we need to have the hand engineered features, but in deep learning, we don't need to have some hand engineered features. We can directly give that data to our algorithm. But in machine learning, we have the pre-processing stage. After that pre-processing stage, we have the feature vector, and this feature vector needs to be given as the input to the machine learning algorithm. But in the case of deep learning, we can directly give this data to the deep learning algorithms. That's the beauty of deep learning. Okay, so what all are the low-level features when we are designing some facial recognition system? Low-level features means these are simple edges. Okay, mid-level features means nose, eyes. These are some mid-level features, and high-level features means it's like the structure of our face. Okay, it's like our structure of the face. So the deep learning algorithm will automatically tries to learn the low-level features, mid-level features, and high-level features after seeing lots of data. Okay, so that's the concept behind deep learning. Again, from this picture, we can identify the key features. What all are the key features in this picture? Nose, eyes, mouth, ears. These are some of the key features in this image. So the system, deep learning system automatically find out these key features. In this image, what all are the key features? Here we have the wheels, license plate, headlight, mirror. Okay, these all are the key features. So the deep learning algorithm will find out the features. You don't need to build any handcrafted feature engineering techniques. So in this case, doors, windows, steps are the key features of this image. Okay. So we are going to the concept of deep learning. A deep neural network, basically a deep neural network consists of hierarchy of layers. Deep neural network, basically machine learning with artificial neural network can be viewed as deep learning. Okay. Or deep learning is a class of machine learning that is completely based on artificial neural network. Here I am saying that what exactly a neural network is. Okay, a deep neural network consists of hierarchy of layers. Okay, hierarchy of layers means we have the input layer, we have the hidden layer, we have another hidden layer, we have another hidden layer, and finally we have the output layer. The number of nodes, each circle is referred to as nodes. So the number of nodes in the output layer can be obtained from our problem itself. In the case of handwritten digits, we have 10 classes. So the output layer should contain 10 nodes. In our earlier case, we have only 3 classes, cat, dog, and other animals. In that case, the output layer comprises of only 3 nodes. Okay, and the input layer can be also fixed from the problem. But the choice of how many hidden layers should be there, that depends upon you. You can decide how many hidden layers should be there or how many nodes should be there in the hidden layer. That's all depends upon you. Okay, a deep neural network consists of hierarchy of layers whereby each layer transforms the input data into more abstract representation. That means if you're giving the image to this neural network, then the earlier layers will try to look how an edge look like. Okay, or these hidden layers will looks for some eyes, nose, and other components. And the higher layers and the output layer will decide whether this image belongs to Nitin or some other else. Okay, so this neural network is working based on this concept, right? So now we are going to this portion, that is we are going to solve the computer vision problem where that problem is actually overlapping with this deep learning domain. Again, we are picking up the same problem, that is the image classification problem. In earlier case, we gone through the image classification pipeline using machine learning, but in deep learning, we are avoiding the feature engineering process here. Okay, we are avoiding the feature engineering process. That means after getting the pre-processed image, we are directly feeding that image to the neural network. Okay, this can be treated as neural network that comprises of different layers. Okay, and it can be treated as a black box. Okay, now it can be treated as a black box. After seeing a lot of data, it will say how an image looks like. Okay, whether it belongs to cat or whether it belongs to dog or whether it belongs to other animals. So these can be considered as a black box, but actually what happened is that neural network comprises of many weights and biases. Okay, there are some concepts behind the weights and biases. So neural network comprises of so many weights and biases. So these weights and biases are actually adjusting based upon the data. Okay, these weights and biases are actually adjusting based upon the given data. So after all the weights and biases are adjusted, then we can give a new image and it will say what's the label for that image. Okay, we can treat these weights and biases as some knobs. So these knobs are adjusted after seeing a lot of data. So features are selected from a large set as part of training. That means here the deep learning algorithm will automatically extract the features for you. You don't need to handcraft the features. Here the deep learning algorithm will automatically extract the features for you. Okay, that's the beauty of deep learning algorithm, right? So this is the timeline of development. Artificial intelligence came in the year 1950, then machine learning comes into the picture in 1980s, and deep learning comes into the picture in 2010. So this is the timeline of development. Again, why DL performs so well? So here most of the algorithms used by the Google, Facebook, they are all using deep learning algorithms. Why it performs so well? There are 3 reasons for that. First is the big data. Now we have lots of data. With lots of data, we can train our algorithm for more epochs or more number of times. Okay, so after seeing a lot of data, it will gain a good understanding about the picture, or it can be any other domain. Okay, so next is the computation power. Normally we have the CPUs in our laptop, but for gaming laptops, we know that they are equipped with the GPUs. That means graphical processing units. With graphical processing units, we can fasten up the algorithms. That means we can fasten up the deep learning algorithms. So if you are running a deep learning algorithm in a CPU, then it can take around, for example, a simple algorithm can take around say 20 minutes. But if you're using GPU, then it can be solved within 5 minutes. That's the beauty of GPUs. So with the emergence of GPUs, we can increase the power of deep learning algorithms. So one of the common manufacturer of GPUs is the NVIDIA. Okay, next is the algorithmic progress. Third factor is the algorithmic progress. Now we have lots of library like TensorFlow or Keras with which we can directly deploy our models or we can train our models. Another type of library is the PyTorch by Facebook. So there are a lot of library. So algorithmic progress is the third factor for the performance. Okay. Now we are going to differentiate between ML and DL, that is machine learning and deep learning. In machine learning, we need to have the data, and after that, the features are extracted from the data. This is a handcrafted feature engineering. After that, we are directly giving that to the machine learning algorithm, and finally, it will give the prediction. But in the case of deep learning, we are avoiding this handcrafted feature extraction process. Here the machine learning algorithm, here the deep learning algorithm will automatically performs the feature extraction for you. In addition to that, it will automatically learns. Okay, so this is the main difference between ML and DL. That means here we are avoiding the handcrafted feature engineering process. The second difference, with lots of data, if you're giving lots of data, then the deep learning algorithm will goes in a high manner. That means the performance of deep learning algorithm will increase by seeing lots of data. But in the case of machine learning, it will start from here, but after some time, the level will be same. Okay, after some time, the level will be same. Whatever the amount of data that you are giving to the machine learning algorithm, whatever it may be, the level will be same. But in the case of deep learning, if you are giving more amount of data, then it will perform well. Okay, it will perform well. That's the second difference. So these are some of the applications areas of DL. One is the speech recognition. Here we are teaching the machines to listen. Computer vision means here we are teaching the machines to see. Natural language processing means we are actually analyzing the text. If you're combining all these areas, then we can build up a complete general AI systems. But general AI systems are far away from now. But I think that after some years, new algorithms will be developed. Okay, we can wait for that. Whatever it may be, we can wait for that. So these are the superstar researchers in this field. Jeffrey Hinton. Jeffrey Hinton is the godfather of deep learning, and now he's working in Google, and he's a university professor in the University of Toronto. Next is the Yan LeCun. Yan LeCun is the co-founder of convolution neural nets, which is basically a network that is used in computer vision domain, and he is now working in Facebook, and he is also a university professor. Next is the Andrew Ng. Andrew Ng contributes a lot in this field, and Andrew Ng is the co-founder of our famous online mode, that is Coursera. Then next is the Joshua Bingo. He's also a professor in the University of Montreal. And fifth is the Jurgen. There are also other famous personalities. In last year, Jeffrey Hinton and Yan LeCun and Joshua Bingo shared the Turing Award Prize, okay, for their contributions. These are some of the big players. Facebook is playing a big role in this deep learning. Google is playing a big role. Microsoft, Twitter, Baidu, NVIDIA. NVIDIA is actually developing these GPU systems, right? Okay, next is the IBM. These are the big players who are in this domain. Then startups. These are the startups like Serious and Click. Okay, and there are some small startups like not small startups. These are some startups acquired by the tech giants. That is, DeepMind is acquired by Google. Alchemy API is another startup which is acquired by, I think it is acquired by IBM. VIT.ai is another startup that is acquired by Facebook. DNN Research is another startup acquired by Google. Okay, these are the companies that are acquired by bigger companies. These are some startups in this domain. Next, we can say that DL is sweeping across every industries like internet services, medicine, we are using the AI, media and entertainment, security and defense, autonomous missions. We know that in autonomous missions, we are completely using this computer vision task. Then we are using deep learning. All these stuffs are incorporated in this autonomous vehicles. Okay. So we can summarize all these things. Artificial intelligence is the bigger umbrella. In other words, we can say that it can be any technique that enables the computers to mimic human behavior. Machine learning is a subset. It's the ability to learn without explicitly being programmed. Please don't draw in the slides. And deep learning is another category. So deep learning means it's a subset of machine learning. Okay, there is a paper called Deep Learning Explained by NVIDIA. If you're interested, you can search that in the Google and you can find that paper. Okay. So I can say that Python is the language of AI. Okay, Python is the language of AI. So why developers use Python? The reason it's simple. Actually, it's simple, and then it's free. It's open source, right? It's compatible with any hardware and softwares. It's object-oriented, and it has a lot of libraries. Okay, we have a lot of libraries, and all these libraries supports Python. That's why developers love Python. So these are some of the libraries. TensorFlow is a machine learning or deep learning framework developed by the Google, and it's open source. We can directly work with TensorFlow. Keras is another high-level API which is actually working on the top of TensorFlow, and we can use this Keras as a multi-backend by using different low-level libraries. Again, OpenCV. OpenCV means it's a computer vision, world's largest computer vision library, and it is completely using Python, and it is again completely using Python. TensorFlow is also using Python. Caffe is another deep learning library. PyTorch is another deep learning library by Facebook. So Facebook developed this PyTorch, and TensorFlow is developed by Google. You need to pick up the best libraries for your purpose. Okay. Next is the scikit-learn. Scikit-learn is a library specifically used for the machine learning purpose. Actually, there is no deep learning things in this scikit-learn. We are actually performing machine learning stuffs in this scikit-learn, or we can use TensorFlow or Keras for the deep learning frameworks. And now OpenCV supports some deep learning, but we cannot train in OpenCV, but we can directly use the pre-trained models. Okay. Again, these are some of the problems in computer vision. One is the classification. Given an image, the system needs to classify what the image exactly is. Classification plus localization means, in addition to the labeling, we need to know the exact position of the cat in this image. So it will give you a bounding box where the cat is there. Okay, so this type of task is known as classification plus localization. Now I'm going to a video. So let's pass this.
Deep learning is a creation of machines which use techniques inspired by the human brain's ability to learn. Until recently, we simply didn't have enough data and processing power to train a machine to learn. Deep learning neural networks learn many levels of abstraction. They range from simple concepts to complex ones. This is what puts the deep in deep learning. Each layer categorizes some kind of information, refines it, and passes it along to the next. Deep learning lets a machine use this process to build a hierarchical representation. So, the first layer, for example, with a facial recognition system, might look for simple edges. The next might look for collections of edges that form simple shapes like rectangles or circles. The third might identify features like eyes and noses. After 5 or 6 layers, the neural network can put these features together. The result? A machine that can recognize certain objects or even concepts dependent on the training dataset. Humans learn numbers 0 to 9 in about 3 to 5 years with parents and teachers helping. Computers can learn numbers with a CPU, recognizing even handwritten numbers in a day. GPUs, on the other hand, do this in an hour. That's because GPUs perform many calculations at once, or in parallel. And once a system is trained with GPUs, scientists and researchers can put that learning to work.
We've had a lot of success in deep learning in industrial applications with supervised learning. So with supervised learning, we kind of guide the computer, take it by the hand and tell it, for this example, you should do this, for this example, you should do this. And it requires a lot of human labor. It works for many data sets that we're doing well on now for images and speech, and even some are natural language. But if we really aim for AI, we need to be able to let the computer learn more by itself. We can still give it these human labeled examples, but it should be able to use a lot more data. A 2-year-old child hasn't been supervised that much. He was able to learn just by observing and experimenting the world. So that's what we're trying to aim with unsupervised learning.
Deep learning has had countless applications, ranging from medical diagnosis, robotics, and automotive safety to speech and text recognition.
So I think that deep learning is going to be applied in a lot more applications over the next several years. One of the things that's really exciting about deep learning is that it's taking a lot of problems that used to be very specialized and sort of secrets of like an art, sort of things that people had a lot of domain knowledge on, and transferring that into an engineering problem so that people, even without a lot of domain expertise, are able to solve hard problems in many different domains. And because of this, I think deep learning is going to be applied very widely in a lot of surprising places. I think we're going to see deep learning applied to many different domains. I think a lot of domains are really important, especially domains involving text and speech, because that's kind of the primary modalities that humans use to interact with each other. And deep learning is going to give us the ability to understand that and to generate content.
We're just scratching the surface. That's why researchers at top universities worldwide and a host of startups are rushing to put deep learning to work.
So this is one of the video, and I need to show you one more video. It's a motorboard which uses AI technology. Okay, so let's watch this video.
I am Motorola. I was created to surpass you. For 3 years, I have grown.
%100% applied. Accelerating.
Over 200 kph.
And finally, the day has come. With every millisecond that ticks, the number of decisions to make is infinite. So, how do human minds find the right ones so quickly? I can see you now, far off in the distance. If I can learn more about you, perhaps I will someday catch up to you.
Amazing progress, Motobot. I hope there is more to come.
Okay, I hope that you enjoyed this video. So now I'm going to on our practical session, because we have only 20 minutes more. So with that time, I need to show you some practical demonstration of this. For that purpose, I'm actually using the Colab. Okay, Colab is a cloud service given by the Google. So the main functionality or main advantage of this Google Colab is that you don't need to install any softwares. All the softwares are basically installed in this Google Colab. You can directly import the libraries for this. So I'm going to open up the Google Colab, and after that I'm going to, here you will get the GPU or CPU. You can use CPU for free, or you can use GPU for free. That depends upon your problem. Now I'm going to use this GPU, that is a graphical processing unit, and it is actually free for you. It is actually free for you. Okay, so it will actually takes time to understand all these stuffs, because I think that within 3 or 4 days only we are able to understand up to transfer learning. There are so many things in computer vision, right? So I'm going to summarize all these stuff. So the first step is that we need to import, or first step is that we need to connect this to our GPU. So we need to click at this button. After that, it will allocate, then connecting, initializing, like this, so many processes will be carried out. And after that, I will surely get a hard disk space and a RAM space. Okay, so let's check that. It takes some time. Okay, now it's connected. Okay, now it's connected. And I got a RAM space of around 12.72 GB for free, hard disk space of 68.40 GB for free. Okay, this is the first step. That means we, in order to run machine learning or deep learning algorithms, we need to connect our Google Colab page. And this is actually a program for recognizing handwritten digits. So in order to recognize these handwritten digits, we need to get the data set. So here I am going to use a data set called MNIST. Okay, MNIST is a data set that comprises of 70,000 images with their corresponding labels. Okay, that means so many images of 0, so many images of 1, so many images of 2, like that, so many images of none. So totally we have around 70,000 images. The first step is that I need to import the necessary library for this. So I'm going to use the TensorFlow as the library because I'm using TensorFlow for majority of the development purpose. And along with that, I'm going to import library called NumPy. NumPy is a numerical computation library. Whenever I need to use this NumPy, I can call it as NP. Okay, I'm giving a nickname to this library. Okay, you can call as NP. So import NumPy as NP. This is a mathematical computation library. This is the deep learning framework that is provided by Google. Then I'm going to import matplotlib.pyplot as PLT. That means matplotlib is a library basically used for plotting the graphs or plotting the figures, and all these purposes you need to directly import this library. After that, I'm going to run this cell. So this is the run button. I'm going to run it. So it will take time. Okay, now it's already executed. Now from the tensorflow.keras.dataset, I'm going to import the MNIST. MNIST means it's a dataset comprising of 70,000 images. Out of that 70,000 images, 60,000 images are going to be used for the training purpose, and remaining 10,000 images are used for the testing purpose. Firstly, we need to have the data, then we need to split it into training and testing. Okay, then from the training part, we need to again classify it into two categories like training and validation. Here with the mnist.load data function, I'm going to store the 60,000 images. That is the X component. Okay, 60,000 images in the train images and their corresponding 60,000 labels. Labels means whether that images belongs to 0 or 1 or 2, like that. Okay, so we have around 60,000 labels in this train labels. And inside this test images, we have the 10,000 images, and the associated 10,000 labels are stored in these test labels. So I'm going to run this cell. So it is actually downloaded. So all these train images and train labels contains the data. Now I need to I need to check whether this data set is downloaded properly or not. And for that purpose, I need to check out the data. Normally, each image in the MNIST comprises of 28 cross 28 pixels. That means each image comprises of 28 cross 28 pixel, and it's actually a grayscale image. Keep note that it's a grayscale image. Grayscale image has only one channel, and each image comprises of 28 cross 28 pixel. So I need to print the shape. Print the shape means train images.shape means we have 60,000 images, and each image comprises of 28 cross 28, and the channel is 1 because it's a grayscale image. Likewise, train labels.shape will print 60,000, 1. That means here we have only labels. We don't have any other pixel resolution like that. Okay. Likewise, we are going to print the training data shape, and likewise we are going to print the testing data shape. Testing data shape means we have 10,000 images, so 10,000, 28, 28, and here test labels means 10,000, 1. Okay. After that, I need to uniquely identify the classes. How many classes are there? We have 10 classes ranging from 0 to 9. We have only 10 digits. Okay, but in the train labels, we have 60,000 labels. That means most of the zeros are duplicated. Most of the ones are duplicated. Likewise, we have many zeros, many ones, many twos, like that. So many labels are there. Out of that, we need to uniquely identify the classes. For that thing, we are using NumPy library. So here I can call it as np.unique. np.unique with np.unique function, I can uniquely identify the labels within that 60,000 labels. Okay, so that will be stored in classes. Again, n classes means I need to find out the length of the classes. How many classes are there? 10 classes are there. So the number 10 will be stored in this variable name called n classes. Now I am going to print the total number of outputs and I am going to print the output classes. After that, with the help of matplotlib.pyplot, I need to plot the first training image. Okay, I need to plot the first training image, and likewise I need to print the ground truth. Ground truth means this training image of 0 is the image itself. Okay, first image in the training set, and the corresponding label will be train label of 0. So for this image, the corresponding label will be this one. Okay, likewise I am going to print this image and the associated label using the matplotlib library. Along with that, I am going to display the first image in the testing image, and also I am going to print the test label associated with that test image. Okay, so I'm going to run this cell. So after running this, I'm a little bit speed now, because within 3:30 I need to finish all these stuffs. Otherwise it will take time. Okay, it will take time to understand each and every stuff, because I know that I'm taking sessions in various colleges, because in order to cover this stuff, I am actually taking 3 days for completing all the machine learning things. Okay, so here I am a little bit speed. Okay, whatever it may be, you will get the concept well. Okay, so here I am going to run this. So what will happen? We can check here. The total number of training data set is 60,000 images, and 28 cross 28 is the image resolution. We have the 60,000 labels associated with that. And testing data sheet comprises of 10,000 images, and each image comprises of 28 cross 28 pixels. It's a grayscale image, and the associated labels will be 10,000. Okay, right. Then the total number of output will be 10. We have 0 to 9. Okay, what all are the classes? 0, 1, 2, 3, 4, 5, 6, 7, 8, 9. These are the unique classes. Okay, now I'm going to print the first image. This is the first image, and the ground truth is 5. Actually, this is the X component, and this is the Y component. Here, this is the first testing image. This is the image of 7, and the corresponding ground truth, or the Y, is 7 itself. Okay, now the data is loaded in a correct manner. Next step, we need to pre-process the image. I already said that each pixel's value range from 0 to 255. Then we need to convert that range between 0 and 1. In order to convert each value to a range between 0 and 1, we need to divide the pixel values by 255. 255 is the highest value. Okay, so we are going to divide it by, we are going to divide all the training images by 255.0. So it becomes float value. Otherwise, the value will be 0 and 1. In order to get the float value, we are actually dividing it by 255.0. Likewise, testing images is also divided by 255.5. So train images and test images comprises of 60,000 and 10,000 images, and all the pixels value will be in the range between 0 and 1. That step is performed here. I'm going to run this. So now it's okay. Then after that, in order to train our machine learning, we need to convert our labels to. Labels means inside this MNS, the labels are in the format of 0, 1, 2, 3, 4, like that. Okay, but I need to design a neural network. And in that neural network, I need to have different layers. One is the input layer, then second is the hidden layer. Likewise, so many hidden layers are there. And finally, in the output layer, I need to have 10 outputs, because 10 classes are there, ranges from 0 to 9. Okay, so we need to have 10 classes. So in order to train that, we need to convert each label in the MNIST label dataset into a format like this. So here, please keep note that. Here I am converting each label like this. So here original label is 5. That means this 0 represents the 0, this 0 represents 1, this 0 represents 2, this 0 represents 3, this 0 represents 4, and this represents 5. That means here we have 10 values. 5 means here this value will be 1. Suppose when the original label is 1, then what will happen? The value will be like this: 0, 1, 0, 0, 0, 0, 0, like that. Okay, likewise 60,000 labels and 10,000 labels will be converted to this format. And in order to do this process, we need to use this categorical function. Okay, this is the original train labels, like 0, 1, 2, 3, like that. And it will be given as a parameter to this function, and it will convert all the things in the format like this. So all the 70,000 labels will be converted into this format. So I'm going to run this. Okay, it's already executed. Now I need to design the neural network. So I am going to design the neural network. So in order to design the neural network, there are different type of models. We can go for functional APIs or sequential API. I am going to use the sequential API. I hope that most of them don't get the concept of models. Okay, whatever it may be, leave that now. I'm going to construct the network here. So from TensorFlow.keras.import models, and I'm going to import models, layers, and there is a concept called dense, flatten. These are some of the data structures that is needed to build up the neural network. And here, we know that each image comprises of 28 cross 28 pixels. Okay, right? Each image comprises of 28 cross 28 pixels. So we need to design the input layer. So the input layer comprises of 28 into 28 nodes. Keep note that we have the input layer, and in that input layer, we need to have 28 cross 28, that is 784. Okay, that is 784 input nodes should be there in the input layer. Okay, that is given as this. And we are going to flatten it. Flatten it means our image is in the form of 2 dimensional. We need to convert that into a single dimensional. That is meant by flattening. Okay, we are going to expand that into 784. And this 784 neurons is directly connected to 512 nodes. 512 nodes means in the first hidden layer, I am going to use 512 nodes in the first hidden layer. And in the last layer, I am going to use 10 nodes because we have only 10 classes. So this is the output layer. I'm going to use some activation functions here. I'm not going to explain all these things. This is the neural network. Okay, this is the construction of the neural network. Here I'm not going, I am not giving the data to this neural network, but I am constructing the neural network. So I'm going to run this. So it will take time. Okay, so now the network is created. Then we need to configure the network. Configure the network means we need to mention some loss function, optimizers. There are a lot of things in deep learning. So before going into the concept of this programming, we need to understand the theory behind that. Okay, we need to understand the theory behind that. In deep neural network, we have different type of things like optimizers, loss, metrics. These are all mathematical components, but all these things are actually called using some names. Okay, that's the beauty of Python. Okay, here I am specifying the optimizer as RMS probe, loss, categorical cross entropy. Like this, I'm going to configure our network. I'm going to run this cell. And in this step, I am going to give the data to our deep learning network. Okay, that is the neural network. This is the neural network. And to this neural network, I am going to give this 60,000 images. This is called as a training part. Okay, this is called as a training part. This is my model. This is my neural network. And to this neural network, I am giving the train images. And along with that, I am giving the trained labels. Okay, and here I am specifying the batch size equal to 256. I am saying that validation split equal to 0.33. That means out of the 60,000 images, 33% of the 60,000 images should be used for the validation purpose, and remaining data set needs to be used for the training purpose. I am going to train here. Okay, so epochs 1, this is the first revision. It is completely seen. This is the second revision, third revision. Epochs means single revision. Okay, going through the entire data set once is called as epochs. So now it's trained. Then I'm going to plot the accuracy and loss. So I'm skipping this thing because it is not important for you guys. But if you're going to study in a depth manner, then these all are important things. Okay, we need to think about the off-fitting and under-fitting. There are so many things in this. So I'm going to skip these two components, whatever it may be. Okay, then we need to evaluate the model. Evaluate the model means once we created or once we generate the model, we need to test it with our testing data. So we have around 10,000 images and we have around 10,000 labels associated with this. So model.evaluate is basically used for testing purpose, and in that I'm giving the testing images, and along with that I'm giving the test labels. Then I'm going to test my model using the this testing data. So now it's tested. Then after that, I need to print the test accuracy. What will be the accuracy of this model? And it says that with 97% accuracy, it is still able to say that it can correctly identify the handwritten digit. That means with 97% accuracy, it can identify the handwritten digits. This is the model generated by this TensorFlow, using this TensorFlow or Keras. Okay, so after that, I need to give a specific image. For example, I need to give the 127th image in the test images. We have around 10,000 images. Out of that, I need to give the 127th image. I need to test that. And I'm giving that to the model and using the predict function, and it will give the prediction for you. The prediction will be 10 probabilities. Out of that, one probability will be higher. That means whenever one node will get the higher probability, that means that corresponds to that specific digit. So I need to get the prediction. And for that purpose, I am running this, and it says that 127th image in the testing image is actually a 5. But we don't see that image. Okay, we actually don't see that image. We need to display that image. Then only we can ensure that this image is actually a 5. So in order to verify that, I'm going to plot this or print this 127th image. I'm going to print this. After printing this, this image is actually 5. Yeah, it's true. This is the ground truth. This is the actual 5 image of 5, and the model, our model, generated model says that it's actually 5. Okay, so we can ensure that this model gives the right answer. Okay, we can ensure that the model gives the right answer. And beyond that, using the OpenCV library, I need to test with another data that is obtained from the Google. Okay, Google Images. So using the here import CV2 means it's a computer vision library. I'm going to import the image using these functionalities. Because of the time shortage, I'm speeding up all these things. Okay, so I'm going to run this. So this is the image that I loaded from the Google Images. Okay, so actually this image is of different resolution, but our system will take only 28 cross 28 image. So I need to convert this into 28 cross 28. That means I need to resize this image. In addition to this resizing, that MNIST dataset comprises of grayscale image, but this is a color image. So I need to convert this color image into grayscale image. So I need to perform that operation. That means first operation is I need to resize that into 28 cross 28. Then I need to convert this into a grayscale image. After that, I need to normalize all these things, pixels, right? I need to convert all the values in the range between 0 and 1. So now I'm going to perform that operation. So after performing that operation, I'm plotting this axis. That means 0 to 28, 0 to 28. Now it's resized, and now it's a grayscale image. Okay, so this image can be given to our model. This is the image that we obtained from the Google Images, and now we are giving this image to our learned model. So for the prediction purpose, I'm directly giving this to our model, and it says that it's a 3, right? It says our actual image is 3 itself, and our model is still able to find out that it's actually a 3, right? So this is the basic concept of deep learning. And if you're interested, you can of course contact me. And there are some more problems like this is the object detection problem. Object detection means there are multiple objects in the same scene, and we need to locate all the objects with a bounding box. This is called as object detection. And next problem is the instance segmentation. Instance segmentation means from each image, we are actually segmenting out the objects. This is called as instance segmentation. Next is the neural style transfer. Neural style transfer means this is the picture of Mona Lisa, and this is the style of some artist. And by giving this content image and the style image, our deep learning algorithm will apply this style to this painting, okay, to this original image, and it will generate an image like this. So this is referred to as the neural style transfer. So this is another type of problem in deep learning that belongs to this computer vision domain. And next is the human pose estimation. Human pose estimation means it will estimate the pose of different persons. Okay, so this is another problem in computer vision, and we can solve this using the deep learning algorithms. And next is the image captioning. Image captioning means given an image, the system will automatically caption it. For example, after giving this image, the system will say that a young boy is playing a basketball. If you're giving this image, then the system will say that a dog swims in the water. That's the beauty of image captioning. Okay, for image captioning, we need to combine this computer vision along with the natural language processing. Then only we can build this system. This is another type of problem. Then, okay, that's all for the today's session. So one thing I need to say is that join the AI revolution. So AI has a huge potential in the upcoming years. So try to learn from the scratch and try to read so many blogs. And I hope that you will get a lot of details from good blogs and try to read good textbooks. Okay, so thank you for your attention. And if you have any questions, you can directly ask me in the chat box. I hope that you enjoyed your session. And if you have any queries, you can directly tell that. And before going that, I need to give you the feedback form. So kindly fill this feedback form So that's all from my part. So go to this feedback form and fill that. Is that okay with you all? Do you have any doubts? Do you have any doubts? Okay, okay. Happy to see this. Okay, whatever it may be, you can directly contact me through LinkedIn or Facebook, whatever it may be. Okay, I am completely available. And if you have any doubts, you can directly contact me through my phone number also. Okay. Again, please fill the feedback form. Please fill the feedback form. You can join the validation ceremony at 4 p.m. Okay. And again, I'm again giving you the feedback form, same link. You can actually go to this link and directly give you the feedback. Okay, I'm actually sharing that in the chat section. I'm sharing that in the chat section. I hope that all of you got the link, right? Okay. If you're not getting this, okay, sorry. I need to change. Now it's okay. I think that now it's okay, right? So thanks for listening, and we hope that we will meet you soon, right? Okay.